If you're going to do any type of wiring on your car, even smaller projects, I picked up this Deutsch connector kit off Amazon. Super sweet. It's got two-way connectors all the way up to like 12-way connectors in here. So it includes all the pins. I think these are for 16 gauge, which is kind of the perfect size wire for most car wiring. You can use these 16 gauge pins all the way down to 20 or 22 gauge just by folding the wire over before you crimp. And I've even been able to fit a 14 gauge wire in these pins as well. So I can convert all the harnesses to DT connectors, weatherproof, weather protected, with some good solid contacts. Hi everybody, how are you? My name is Dan Dulac and welcome back to my channel where we are building a V10 powered Ultima Evolution convertible. This is episode number 34. If you missed any of the previous 33 episodes, be sure to go back and check those out on my channel. We have done a lot to this point and we are getting very, very close to getting this car started for the very first time. Now, as you can see, I reconfigured the garage a little bit, put it in what I call summer configuration mode. I've got the V8 supercharged Cobra here, the V12 Aston Martin Vantage, I've got the 2JZ Supra sitting over here, and of course, the project, the V10 powered Ultima Evolution. Now, in this episode, we're gonna continue to work on the wiring. We are gonna finish up some of the wiring in the engine bay. We're gonna continue working on the cockpit wiring, as well as some bits that I custom fabricated around a speed sensor gear and the bracket holding the speed sensor, as well as a few other things. So, without further ado, let's get to work. Here's the speed sensor gear I created in Fusion 360. Measured this out on the rear axles that I just received that I showed you in the last episode. 3D printed a pair just to make sure they're fit, and then sent them to OSH Cut. And I had them cut them into basically two pieces per side, the way that I'm gonna mount those up. Just split the ring in two. So let's see, here's what they sent me. Very nice laser cut. I mean, the precision cut on this is really nice. So these are target gears for the speed sensor so that I can route the speed sensor into the ECU. All right, here's one of the axles, the short boy. And let me show you how the speed sensor gears I had made are gonna fit on here. So again, I shipped them the original OEM pair of CV axles, so they repurposed the inner joint, and this is the outer 108 millimeter joint that's new, of course, with a custom hardened shaft there. So the way this fits into the axle is just like that, and then 6 bolts go through and secure it. Now, what I was thinking of doing was sandwiching a speedo gear in between the two, between the axle and the pinion here. But given that these axles the length has been measured very carefully to give me the right motion and in and out movement, I didn't want to disrupt that at all. So what I decided to do was make the gear so that it bolted to the outside, right on the outside. But since these are already put together, no way in heck I'm taking these apart to slide on a speed sensor gear. So that's why I had them cut them cut the ring into basically two pieces. So now let me show you how this is going to work. So here's the ring in two pieces. One side goes on, the other side goes on, and then these are the OEM bolts, and you can see there's some C-clips here. I don't know what these are. These are kind of like washers. Really don't know what they're for, but as you can see, when we slide these in, it'll kind of close up the seam there and lock it into place. Just like that. Like that. So there you go. So this will bolt up just like that. I'll snug these in, and the bolts are plenty long enough. I think this is only not even a 1/8 inch steel, this ring. I forget. I think it's maybe 20 gauge. I can't remember what I ordered, but it's pretty thin. It's stainless, so it won't rust. And then I will hook up, I'll use one of these spare mounting holes to hook up my Hall Effect speed sensor. Got a 3-pin Deutsch plug there, Deutsch connector, and then I'll make a little bracket or something to come out to mount this speed sensor into so it reads off the target gear.
Lot of boring math later.
All right, I made up this little bracket. This is a 3D printed bracket with the carbon fiber nylon. Put a heat set thread insert in there, and then this goes together. So let me put this together, then we'll put it on the transmission and show you what it looks like. All right, there it is. I've got it set. The sensor wants to be between 1 and 2 millimeter away from the target, away from the gear. And that's pretty much where it's at. It's about 1.5 millimeter. So that should work. I thought about making this bracket in aluminum, just a very simple aluminum bracket, but I just figured I'd model one up in Fusion 360 real quick. I printed this the 100% infill. So again, given this is carbon fiber infused nylon, it's very stout and very rigid. So this should work nice. It just gave me a lot more control of the simple design. I probably over-engineered this bracket, but it's there now. So let's run with it. I'll zip tie this harness down here, and then it's got a 3-prong Deutsch plug in there that'll just wrap right into my harness. So perfect, that job's done. All right, I've been up to a lot of wiring on this car, slowly making my way through it. Let me show you guys where I'm at. I'm almost done with the engine bay, and all my attention focuses into the cockpit now. So let me show you where we're at. Let's take a look. All right, passenger side. I've got the fuel pump wiring with some heat shielding all set. The fan is wired. I used some DT connectors, Deutsch connectors there. And if I ever have to replace this fan, simply unplug it right there, unbolt it, and away we go. And then the wiring on this side, I've actually got passing into the side luggage bin. I have a small 1-inch hole with grommet. You can't see it, but it's in there. And on the other side, I've got some looms passing through there that go through there, out, and then into the cockpit. So that's what I'm doing on this side. nice and clean, good to go. On the driver's side, I've got just the fan and the fuel level sender unit. You can see the fuel level sender unit there. The harness passes under the bar. And then for the fan, I've also got a DT connector. You can see back there. Again, so if I have to replace this fan, simply unplug, unbolt, and we're done. That harness kind of passes under the body and comes out down here, down behind the sump, and then into this 6-pin plug that will plug into its counterpart that was going to hang off the main harness here that plugs in, so that I can detach it. If I have to remove the engine, I can simply unplug these two, unplug a couple connectors, and I could just pull the entire engine out easily without any other harnesses to worry about. And speaking of fuel level senders, these are resistance-based units. There's one on each side, and I think the full is 2 ohms and empty is 72 ohms, or vice versa. I can't remember which, but that's the range there. And what I did, so that I can have a nice fuel level gauge on my Motec display, I picked up one of these. This is a simple voltage divider. And basically what this does is this converts the resistance to a voltage setting from, say, 0 volts to 5 volts, depending on the fuel level. So that'll be nice. And then I will connect both tanks to that, so I can actually see fuel level on both tanks. These tanks should self-equalize. Way back when I first put these fuel lines together, I've actually got 2, you can see them down there. They're 2-6 lines that string between both tanks so that fuel will equalize between the two. But I'm going to have one of these units that will show me, put it on a switch, and that will show me both sides so I can check those. Now, one of the other things, speaking of fuel system, on this car, and because I'm using the stock ECUs, I am going to use this pulse width modulator, pulse width modulation fuel pump. So this is the OEM PWM, pulse width modulator, easy for me to say. And I've got the wiring diagram so I can easily connect up those pins, no problem. But there's no clean way to mount this. So you know me, I went to Fusion 360 and I designed up just a little plate that will mount into the chassis. I think I'm going to mount it in the footwell area where I've got my other modules. I'll mount it there, use some flat-headed screws, and then the way this goes together is there's a couple of notches here that you can see. They slide into the notches here on this, just like that. And then on this side, they just slip down into a couple of notches, and then a little clip, just a little clip right there to hold it in. So that'll hold it in place, and that'll let me plug this in and give me some way to mount it into the chassis. I've also got my throttle pedal wired up. There's a 6-wire harness right here, as well as the brake pedal switch. That's wired in, and then I'll run those wires over again into the footwell area where they will hook into the harness very nicely. So it's starting to come together here. I still got obviously quite a bit of work to do. I've got to take all the PDM wires and route them over to where they're going to plug in there. But took the driver's seat out just to give me room in the cockpit. I've got the car up on jack stands and making good progress there. Now let me show you something else I did over the last couple of weeks. With this car in the air, on the on the passenger side, the tire would almost hit the bodywork at full suspension droop. Now the suspension is not at full droop, and you'll see why here in a moment. But to the point where it didn't quite touch, but it was close enough where it was very difficult, if not impossible, to get the tire on and off with the car lifted off its weight, where the suspension was in full droop. So that was one thing I wanted to look into addressing. And then the other thing is I've done a ton of measurements. Obviously, as I had these custom CV axles created and built for me, given the short length on the passenger side, I don't have a lot of angle to play with. There's about 15, maybe 20 degrees, probably 20 degrees there of angle, but I'm concerned, given how short that is in the engine or the suspension at full droop, that it might put undue strain on this CV joint when the suspension is at full droop. So here's my solution. What I did is I installed some limit straps. And so what you see here is a 9-inch limit strap, very tight because again, it is holding up the suspension just a little bit. And I picked up some, this is a 1.5-inch roll bar bracket, bolts on, clamps in place, and then a 1-inch on the lower side to clamp the suspension on. And what I did was, this is obviously now adjustable. So if I slide this out, I've got a little bit of room here to move this out even a little bit more if I wanted to raise up, further limit the suspension droop, or slide it inward and that would relax it a little bit more. So there is some adjustability there. Everything clears, it's out of the way. The other thing is with this lift, again, I don't want it to lift. I think the lift is about 2 inches and it should be fine. But again, a limit strap will help, again, prevent the tire from hitting this bodywork or even helping me, so it's easy to get the tire on and off. So yeah, so that's the situation there. It's all bolted in place, it's solid, and that should work just fine. Now on the driver's side, I had a little bit more room. I could get the tire on and off easily, but just for the sake of symmetry, I put a limit strap over here on this side as well, and that is good to go. So I think I've got those issues straightened out. I won't have any issue with, again, because of the short CV axle, I'll have the limit straps there so it doesn't put any undue stress on those when the suspension is at full droop. Now, in addition to hosting all the videos and sharing this build with you guys on YouTube, one of the other key reasons I did that was to get some support and some help. I've done a lot of work on cars before, so a lot of it isn't new, but there are certainly some tips and tricks I've received from all of you guys. I can't thank you enough for all your comments. So if you have any other comments, leave those down below. I'd love to hear it. And I've been taking and heeding the advice on many different things. And one of the things I did recently that I wanted to share with you is the following regarding a lot of the coolant pipes and specifically the bracketry to attach the coolant pipes and the hoses together. So let me show you what I've done here. So what I've done with all the cooling plumbing and specifically the clamps is I converted and removed all the worm clamps and replaced those with spring clamps. You see spring clamps used a lot on OEM applications. If you don't have the right tool, they're somewhat of a pain to work with, but I did get a spring clamp tool that makes that very easy. Now, the reason you want to use spring clamps versus worm clamps is the metal expands and contracts with heating and cooling cycles. And over time, with the worm clamp being fixed, it could develop a leak. Whereas the spring clamps, as the name suggests, they have a spring to them, so they will expand and contract as those cooling pipes expand and contract through various heat cycles. So for all of the various cooling pipes, I've got spring clamps in place from the large 1.5 inch to the smaller 1 and 1.5 inch. So anywhere I have a cooling intersection or junction where I need to clamp, I am using spring clamps. The other thing I did up front, if you can remember way back, I had a corrugated stainless steel hose here. I actually took that hose because it was the right shape over to my local auto parts. They let me in the back room where I could just find the appropriately shaped rubber hose there. I put that in, again, with the appropriate spring clamps on both sides, as well as on this side. So you can see I've got spring clamps there. So the entire cooling system has spring clamps, and with the right tool, again, I'll show you the tool. This here is a spring clamp tool. You put your clamp here on one side. It's got this long flexible cable so you can reach in hard to reach places. And it's got a locking mechanism here so that you can hold the clamp completely wide open, slide it on, release the clamp, and away you go. So that is the tool. That works great. Pretty cheap tool as well. And that makes a world of difference in working with those clamps. So guys, that is it for this episode. I am awaiting, next week I should be receiving the complete exhaust system that is fully heat shielded. That's gonna let me reattach the headers to the engine, get the engine, the trans, all the wiring, all the plumbing. We're gonna start putting fluids in this thing. That's gonna give me some incentive to get this cockpit all wired up, putting power to the system so we can get this thing started for the very first time.
Swing! Swing!
So until then, we'll see y'all soon.